This is for statistics. We're going to do some examples on 12.2 two-way ANOVA. So given the verbal IQ score, IQ verb in the IQ lead file, so this is coming from the file name. Use a two-way analysis of variance to test of an interaction effects. An effect from the role factor, in this case consider sex, and they will label 1 as male, 2 as female, and an effect from the column factors of the blood lead level, 1 for low, 2 for medium, 3 for high, use a 5% significant level. So usually I wouldn't even include the word two-way and analysis of variance here, so you have to know that this is a two-way ANOVA because you got two factors here, the row and the column. So first you have to check your requirements. So the first step is your requirement is a normally distributed. Again is robust, so we assume it's yes. The population is an equal variance, so again it's robust, so we yes. We assume yes. Simple random sample is yes because it comes from the file name, so all file name is simple random samples. Independent is yes, so every person in this file name is measured independently. Two-way, you have two yes in the way because we got two factor, the row and the column. So that's why it's a two-way ANOVA. And balanced design. So in this case, the balanced design is a little bit hard to see on your data file. This is your data file. It's because you have to figure out how many ones and how many twos and how many threes do we have in this case. You will notice that when you do this, if your design is not balanced, your two-way ANOVA, you will be giving you an error message. So this one we can kind of figure out later on. So but once you put into your R, then you can tell that it'll be yes. If it's no, if you find out that you put in two-way ANOVA and they give you an error message saying that this is not equal or something happens, that means your design is not balanced in this case. So the sampling distribution is F. So no matter you're doing an interaction test or a row test or a column test, your sampling distribution is F. So don't forget ANOVA is always F distribution. So how do we do this is you use M equals to read table. So I use the M equals to read table, and then you pick the file name called IQ lead. And this is the file name for IQ lead, so IQ lead. So so we have three important variables here: the lead level, the sex, and the IQ verb. So those are the three important part. The IQ verb is the quantitative variable. The lead level, 1 stands for low, and then you will see 2 here, which stands for medium, and then 3 here stands for high. And then if you look at your gender or your sex, 1 and 2, 1 here stands for male, 2 stands for female. So this file does not label your lead and your sex based on the categories they want. So in this case, you have to label your categories based on your level. So that's why A in this case is factor, M is sex, because we want, this is your row factor, which is sex here. And so levels is 1, 2, because you only got 2 levels, 1 and 2 levels. And every labels in this case is M and F. That means it tells R that every one under sex here is going to be labeled as M, and all the 2s here will be labeled as female, F. And then because your lead level is also 1, 2, 3, so you have to label them. So for B in this case, which is your column factor, is M minus sign lead. Level equals to C, 1, 2, 3, because you got 3 levels. 1 is considered low, so I put L. 2 is considered medium, I put M, and 3 is considered high, is high. So what we are doing here in this case, when I put this factor, is just labeling your file name, because your file name doesn't give the M and F for gender and LMH for your lead, because it just gives you number 1, 2, 3. So this is how we label it. And then X in this case is M IQ verb. So this is a nicely done because this is all in quantitative. So there's no labeling here. And then you do the summary AOV X tilted A times B. So once you get this, so you begin to label this. Make sure you have double closing parentheses here. So this is what the results will get. So we will always concentrate looking at the A, B first. because that's the interaction test. So this is the first thing you do here. It's an interaction test. So how do we perform the hypothesis statement here is the IQ has no the IQ score, the verbal IQ score has no interaction between the sex. So this is always no. And then the null hypothesis, the verbal IQ score has an interaction between the sex and the blood level. So this is actually talking about both cases. When you talk about interaction, we talk about both cases. And by the way, since if this run really smoothly, means that it is a balanced design in this case. Okay. So so step 2 here is when you do interaction test, means we're talking about both factors in this case. Okay, both factors in this case. So so that's why you do this first. So with test statistic here, which is 0.061, and the p-value here is 0.941, and you find out that your p-value is greater than alpha. Alpha in this case is 5%. So you will say that there is not sufficient evidence to warrant rejection, that the verbal IQ score has no interaction between the sex and the blood level. So this one you have to continue to row and column. That means you have to do all 3 tests here. The reason why is because you say there is no interaction. So if you have a no interaction here, you have to continue with that means you're supporting your claim here. You're supporting your claim, so there is no interaction, so you have to continue in this case. So what happens in this case when you do the row test here? So in order for us to do the row test, your row is about gender or sex. So the verbal IQ score has no effects based on sex, and the verbal IQ score has an effect based on sex. So for the hypothesis statement for row is very clearly stated that this is for row, which is based on sex. So for this case, we'll be looking for just for A. And the test statistic in this case is 0.351, and the p-value in this case is 0.555. Again, your p-value is greater than alpha, so we will reject the null hypothesis. And when you reject your null hypothesis, your conclusion also say that there is not sufficient evidence that to warrant rejection, that the IQ score has no effects on sex in this case. Okay, so one has no effects on both sex and the blood level. So now we are doing just seeing what happens if you have just the factor for sex. Now we're going to do column factor, which is in this case is your blood level. So so the null hypothesis there is no effects based on the blood level, and each one has effects on the blood level. So now by looking at your R, we're looking at your B in this case. So your test statistic in this case is 0.347 with a p-value of 0.707. So that means that again your p-value is greater than alpha. We fail to reject your H0. So based on this, there is no sufficient evidence to warrant rejection that the IQ score also has no effects based on the blood level. So that means that if you look at all this conclusion, there's no interaction between both. There's no effects or no effects based on just the row, which is sex in this case, and there's no effect based on the column, in this case the blood level. So this is the final conclusion. So every time when you guys do a two-way ANOVA, you have to tell me the final conclusion. So the IQ verbal score here has no effects based on sex. It's also no effects based on the blood level, and it also has no interaction or no effects based on both sex and blood level. So this is the one that you have to do in your last, this is very important final conclusion here based on everything. So this is how we do what we call as a two-way ANOVA. If you have to do all 3 tests, the reason why is because there is no interaction between both of this. So you want to figure out, is there interaction between either the column, or you have interaction between the row. So based on this, we can tell there is no interaction between both of them, just the row or just the column. Another way we can figure out is just looking at your test statistic, your p-value here. You find out that all this p-value is bigger than 5%, so we can directly conclude that there is no interaction between both. There's no interaction between sex, and there's no interaction, there's no effect based on your blood level. So you can tell directly here. But unfortunately, you have to go through all this testing here for your points. So this in your test will worth around like 12 points, 12 to 15 points here. So make sure you guys understand how you do this question in your homework and in your test. Sometimes the good news is they provide you this result. So if in the test, if I provide you all this result, then you do not need to put it in your R. You just use this result to do the interaction test. So sometimes I will give you this result to just make your life a bit easier, so you do not need to type in all this R into your R programming, all this syntax. You just look at this result and do your hypothesis testing here. And some of you can even look at it by just looking at all your p-value here. They are too big, so you can tell that all has no interaction, no effects on everything. Okay.